Let's dedicate this lesson to some of the more popular project management tools. Effective tools can either be quantitative or soft. As always, remember to consider only using tools that present a benefit to the project. Work breakdown structure is a detailed plan which expands the project into a detailed listing of activities. Project tasks are broken down into finer elements until a specific responsible party is identified. Work breakdown structures promote accountability and transparency. This allows elements to be situated in parallel as opposed to series as you would see at the activity level. This also enables project managers to accomplish more with fewer multifunctional resources. Some other planning tools in a separate category from project documentation consists of Pert, CPM, and Gantt charts. Unlike work breakdown structure, these planning tools ignore project costs in favor of timing. Pert is program evaluation and review technique. The requirements are inclusion of all project events to determine the critical path, time estimates for each activity, a range of values is advised, liberal, most likely, conservative. Critical and slack times are calculated. The critical path is the sequence that requires the greatest time. Slack time is the latest time an event can occur, less the earliest time an event can occur. Events on a critical path have a slack time of 0. An event at the start of an arrow must be completed before the event at the end of the arrow may begin. The expected time, TE, is given by the formula shown. TO is the most liberal time. TM is the most likely time. TP is the most conservative time. These are the 3 time estimates used for each activity. Some advantages of Pert include: it helps to uncover interrelationships between tasks and problem areas. It is used to find the probability of achieving the project deadlines. This helps to limit risk. Changes can be made, measured, and compared. It is capable of handling a large amount of data. And it is useful for unique, non-repetitive projects. Pert does have some disadvantages. First, Pert is complex and increases implementation problems. Also, network inputs require more data. Here is an example of Pert. On the right, there is a Pert chart. The circled numbers represent the start and end of each event. The arrows are the tasks, and the numbers below the arrows are the durations for each task. On the left, a tabular representation has been generated. Events have multiple arrows coming out are called burst points. Events that have multiple arrows coming in are called sync points. Event 1 would be a burst point, whereas event 5 is a sync point. To calculate the critical path, we add the times of each possible path. These paths and the times are shown in the table in the bottom right. The critical path would be the longest duration. In this case, 0, 1, 3, 6, 7, 8, 9. Events not on the critical path can be delayed by the slack time and not affect the critical path. Suppose we wanted to find the slack time for event 5. Note that event 5 has 2 arrows coming in. Both must be complete before we can start event 5. Therefore, the earliest time we can start event 5 is along the path 0, 1, 2, 5 at 15 weeks. The other path, 0, 1, 3, 5 at 9 weeks, is completed 6 weeks before event 5 can begin. Event 5 has 1 outgoing arrow to event 8. Event 8 is on the critical path and occurs at 20 weeks. Since 5 through 8 takes 4 weeks, the latest that event 5 can begin will be 20 minus 4, or 16 weeks. Therefore, the slack time will be 16 minus 15, or 1 week. The critical path method is very similar to Pert. Pert is organized by the event, whereas CPM is organized by the activity. Some may consider the difference between events and activities to be semantics, but in terms of the Pert and CPM, there is a difference. Events include the beginning node and the ending node in the Pert diagram. Activities in Pert are the arrows between the nodes. For this reason, an event consisting of the same activity between nodes 5 and 8 would be different from an event between nodes 4 and 12. CPM focuses on activities and considers the time and cost. Only activities on the critical path are considered. CPM uses an idea known as crashing. Crashing is the act of adding more resources to complete the activity in a shorter time. Activities with lowest crash cost per incremental time savings are given the most attention. As activities are crashed, possible new critical paths can develop. CPM is much like a cost versus time trade-off method that allows project managers to meet deadlines by adding resources. Clearly, there are limits to how much can be done. CPM allows the project manager to zero in on the best cost for time trade-offs by activity. Above is the CPM for the previous Pert example that was showcased. Note that the activity and the duration are noted inside each circle. The critical path is denoted by the blue arrows. Let's explore this further. The table above shows crash duration and cost for each activity. The time to do the project normally is 21 weeks. The total cost to complete the project is $41,650. Recall that is A, C, G, J, K, L. Suppose leadership states that we must complete the project in 20 weeks. To do this, we will need to trade time for additional cost. Looking strictly at costs, activity E would be the best choice to accelerate. The cost is minimal. However, activity E is not on the critical path. Any change we make to reduce the delivery of the project to 20 weeks must involve an activity on the critical path. Recognize that some activities on the critical path cannot be accelerated. In other words, the normal time and costs are the same as the crash times and costs. The best choice is to accelerate activity A by 1 week. This will increase the cost of the project by $300 and make the total after crashing to 20 weeks at $41,950. Crashing activity A to 1 week requires us to recalculate the critical path. We see that making this change does lower the critical path to 20 weeks, but does not change the critical path. Gantt charts display activities or events as a function of time. Each activity is shown as a horizontal bar with ends positioned at the starting and ending dates for the activity. The advantages of Gantt charts are that it is easy to understand, changes are easy to implement, and it only requires a minimal amount of information. The disadvantages are that there are no interdependencies of activities, it cannot accommodate early or late starts, and variances on time to completion. Detail of an activity is diminished, and it is not as powerful in predicting the likely timing of completion as other methods.